I'm going to talk about computer vision for manufacturing automation and especially about no-code approaches in practice. I know that this audience is maybe mostly the developers with different backgrounds, more or less technical, but you still might benefit from what I'm going to talk about. Because even the developers and people with deep background, technical background, use these tools, and I'm going to talk about and show you. My name is Olga Perepelkina. I work at Intel in Industrial Robotics Division. I'm also mentoring some startups through Intel Ignite program and also collaborate with university and academia, for example, with the University of Glasgow. I'm located in Munich. Here is my LinkedIn. Please join and let's connect. I'm going to talk mostly about the experience I had through collaboration with Intel Foundry. So just to highlight, Intel is a huge company, and basically it consists of two sub-companies, I would say. So one is Intel Product, where we design the chips, where we design the products, and where we sell the products and also develop software tools I'm going to talk about, and I belong to Intel Product. But there is also Intel Foundry, where we develop the chips, where we produce the wafers, where we do assembling and test manufacturing and supply chain. And Intel Foundry is distributed across the globe, from the US to Europe to Israel to China, Malaysia, and Vietnam. And we have like thousands of people working there and developing millions of chips. When we develop these chips in Intel Foundry, but not only, of course, in any foundry, but I would more show some examples from Intel Foundry, we usually want to automate what is going on in the factories. So why it's important? So when I was visiting once the Intel Foundry in Ireland, actually I was amazed on how advanced this place is. So maybe it's one of the most advanced manufacturing processes in the world, at least what I visited. So for example, there are a lot of robots already in the foundry. There are almost no humans. And the robots are like going on the ceilings and distributing, for example, the wafers across different types of processes. In assembly and test manufacturing, for example, in China, in Vietnam, there are more manual operations, and there are a lot of operations with human eyes. And for example, quality control and inspection is still highly reliable on humans. And of course, we don't want humans to spend their lives on these boring tasks, and it's not efficient, and people are getting tired, and there are many errors. And we heard that from the first talk, from the first brilliant talk on this webinar, which Matt presented, that it's very an inefficient process, and of course it's expensive, and that's why factories across all the globe want to reduce this dependency on humans and replace with computer vision based inspections and save some money. We deployed multiple projects in Intel Foundry across a couple of last years with just a single tool I'm going to show you today. I want to highlight just a few of those projects which we deployed in production. So, for example, damaged box detection. So, of course, in Intel Foundry, there are a lot of logistics operations, and we ship millions of boxes to our partners and customers. And if the box is damaged, of course, it means that the product inside can be damaged. That's why it's very important to track these damages in time. And surprisingly, it's still highly reliable on humans. It may be, again, not very efficient process, because even in boxes, there are multiple types of damages in the box, and there are different processes associated with different damages. And the team, an internal team in Intel Foundry, they developed a system a computer vision based inspection and some mobile application to automatically detect these different types of boxes and damages, and then send some automated alerts to business owners and to prevent the further damages and inefficiencies in logistics. And that's how they improved accuracy and reduced inspection time across the entire organization. One more example is about Intel Foundry in assembly and test manufacturing. Here you can see on this slide the semiconductor devices, the socket, and we need to inspect all the different types of damages on the socket. And here you can also see on the left bottom slide multiple types of the damages, and actually each of the test inference units, it's how this device is called. It requires like 20 to 30 minutes per device when the human operator is inspecting it. And of course, it's a very time-consuming and boring task, and people are getting very, very tired. And actually, also this unit is quite heavy, and people need to inspect it from all the dimensions, and they need to rotate it. So it's very inefficient process. And the other team developed the solution with robotic arm, with cobot, which makes multiple images. So basically, it's automated camera to make multiple images across the test unit from all the angles, and then automatically inspect these images with computer vision models. Yeah, so basically,
what we have here is our
I don't know if you hear the
assembly test area.
what the guy is talking
about this is we leverage
can't hear that.
networks in order to optimize our inspection. So what used to take technicians 20, 30 minutes now takes less than 5.
Yeah. And one more project, also from Intel Foundry, but already from factory facilities monitoring. The problem was that a lot of staff in Foundry facilities need to be also monitored by humans. And basically, it's also a very boring task. So human operators have to go into the Foundry facilities and look into different like gauge, for example, or liquid tank, and inspect the level of liquids, for example, of toxic liquids. Or also just look if some goods are absent or present, and they need to do it several times per day. The team decided, okay, let's automate it and develop a few computer vision models and deploy it inside the robotic dog into Boston Dynamics robotic dog. And now the dog is running instead of humans across Intel factory facilities and doing the same job. When we started these projects and when we started to talk to the customers, not only with internal but also external customers, so what they shared with us. So first of all, many of existing tools in factory, they already have cameras, and they might have even some built-in computer vision inspection tools. But what our customers shared with us is that these existing tools, they usually have, they quite old because to update the entire factory is very expensive. That's why once you build the factory, you will use it for many, many years. And some of those tools, many of those tools, they usually use traditional computer vision algorithms, not deep learning, not machine learning based algorithms. That's why you cannot update the model, you cannot fine tune the model. And of course, for real world production environment, they show very poor performance. Then you can, of course, use some open source AI models, and there are many, many models in the world. But of course, they are very generic because they are trained on just internet data, and they will fail in some specialized use cases like manufacturing defect inspection. Of course, you can go to some third-party vendors and develop a model, but of course, it's time-consuming and very expensive. Or you as a factory operator or factory worker, you can develop your model by yourself, but of course you need to have some experience in Python and be a developer and know all these tools. That's why, and at the same time, all the subject matter experts and model engineers, like quality engineers, they all have this knowledge about the quality control, different types of defects in their heads. And actually, in particular in Intel Foundry, those types of defects are very, very complicated. So it's almost impossible to explain to the data scientists what are the differences. So you really need to give this tool to the subject matter expert. So the question is how we can transfer this knowledge from the head of subject matter expert into the AI model. And the similar question would be for healthcare, for example, where also the different types of classes will be very, very specific, and we need this subject matter expertise to label the data sets. And in Intel, we have a tool which is called Intel Getty. You can consider it as a personal computer vision AI buddy. When we can combine the subject matter expertise from the main expert with the computer vision expertise from Getty. So it's free, no-code tool. It's accessible on GitHub. It's on-prem. That's why it's secure and reliable. It can be installed on desktop or on cloud. And we always and continuously update the models, so you can find their state-of-the-art models, and you can quickly develop the models. And basically, almost no data science expertise is required to get started with this tool. And one of our healthcare customers, early adopters of this tool, once mentioned that what's unique about this tool is that it feels like an additional member of our team. And we really hope it's true, because it was the goal for this tool when the team started to develop it. So Getty consists of multiple libraries. So for example, Anomaly, which Paula mentioned, and I believe that tomorrow there will be a dedicated talk about this tool, and as well as many other tools. For example, OpenVino, some of you might heard about this, the tool for model optimization, and some other tools are part of Getty infrastructure. So by using Getty for subject matter experts, all these tools are part of the ecosystem, and they don't even need to use these libraries separately, because it's all integrated into one no-code tool. And as I said, it's used not only in manufacturing, but also in like healthcare and life sciences, in retail and education and many other industries. But manufacturing is the biggest group of our customers and users, because probably this tool is really, really useful for them. Okay, I would like to quickly show a demo. Let me reshare my screen. I know we're getting out of time, but I would be very quickly. Okay, hopefully you can see my screen again.
We see your screen.
Amazing. Okay, so this is a no-code tool, as I mentioned, and we support multiple computer vision projects like detection, segmentation, classification, anomaly detection, key point detection, chain tasks, when you can combine multiple tasks. So let me, just from interest of time, let me go to the existing project. So it will be the classification of the bottles. So for example, we are a factory which produce bottles, and we need to distinguish between good and broken bottlenecks, a very important part of the process. So you start with uploading data in the project, and we support multiple formats and types of files. So for example, videos, images, different types of formats of the images, and also you can export existing data sets. We support all the major formats like YOLO, COCO, and stuff like that. Then you label your data in the platform, and we support all the different types of labeling tools, very convenient for classification, detection, and segmentation, and all the other tools. And once you labeled your data, you can train a model. And Getty will trigger the model training automatically once it has enough data, but you can also customize this process. And currently we support multiple architectures per each task. And for people with experience, so for subject matter experts, they can just trust the tool and just use the default model to get started with the model development. For data scientists, we support all the required customization, and you can control what you develop. So you can manage your split, you can customize your augmentation, you can customize your training by changing some hyperparameters, and of course you can select different architectures. So once you train the model, then you also can test it. We provide different types of adding, like you can add multiple testing sets and then test the quality of the model on different testing sets, for example, in different lighting conditions, different angles and stuff like that. Then you can also optimize the model. So basically, we support different types of optimization of the models and different types of precisions of the model. So it can be FP32 or FP16 or int8 optimized model. The models are optimized with OpenVINO, the open source tool. And then once you tested the model and you're satisfied with the performance, you can take this model from here and download this model and deploy into production environment. To be able to deploy the model, you will need to use some low-code tools we provide, Getty SDK, but it's also very intuitive and user-friendly. So again, for subject matter experts, they do still require for deployment some, of course, knowledge, some engineering knowledge, but they don't need to have a deep computer vision expertise to get started with that. Okay, amazing. So what I just quickly showed, I wish I had a bit more time. So you develop the model, no code, in the Getty application, and then you get your model, and with low code, it's very simple. You deploy it. You deploy the inference on your edge device. And so since the model is optimized, it can be really run on very low power hardware. So for example, like on devices like this, it's Intel Atom processor. So it's very, very cheap, a little bit maybe more expensive than Raspberry Pi, but all the Getty models or most of the Getty models actually run quite well on this type of devices. Or if you need more performance or more FPS from the model, of course, you need to have a more powerful device. But as models are optimized, you can deploy actually across all variety of Intel silicon, and that's why Intel actually is doing this product to monetize our hardware. And what is nice about Getty that the whole development process is very simple and intuitive. And I want to share this quote from our internal user, from manufacturing engineer from Intel Foundry, who tried to build this project with Intel Foundry facilities inspection, and they tried to build the models and trying different tools and spent about 1 year. But then we introduced Getty to them, and just for a couple of days, they managed to build the system and deploy it. And now they use it for more and more projects because the whole experimentation process is very intuitive and simple. Some other insights from our customers, from the real world deployments from Intel Foundry and manufacturing examples. The main difference between research and industrial application is the goal, of course. So in research, the goal is to create some new algorithms and approaches, and usually we show the differences of these approaches on some existing benchmarks. for example, ImageNet or some more modern data sets. In industry, we do not care about the performance on some existing benchmarks. We do care about the performance on real world data, right? And on industrial data. And the goal is to apply existing algorithms to industrial data. And that's why we want to monitor our model and update it as quickly as possible if we see that model performs not really well. So that's why we need to iterate really quickly. And that's why the tools like Getty can be very, very powerful and useful, because the whole beauty of that you don't need to spend on experimenting a lot of time. You can do it very, very quickly. So you can develop the new model in times, in days, or in hours, actually. And Paul already mentioned the importance of data-driven approach in industry. I just want to highlight again this idea that indeed we do care about the data more than about the model in industrial applications. And that's why we spend a lot of time talking with customers how to collect the data for their projects. What does it mean to have a good quality of the data? Sometimes they try to start a project with a very complicated problem, and we ask them to simplify it to some minimum problem they want to tackle first, and start with small data sets, because in Getty we use fine-tuning. It means that all the models are pre-trained already, and that's why to have a reasonable quality you don't need huge data sets. Like sometimes we see in production the projects with data sets of just hundreds of images. So you don't need like millions of images to be able to develop the model. And it's better to iterate quickly than to spend a lot of time on collecting huge data sets. And of course, it's important to analyze the mistakes in production and to review the quality of the annotation. So for example, sometimes we see that just labels can be missing or wrongly assessed. And it means that we need just to improve the quality of notation instead of trying to get to change the model architecture. And also we can try different annotation strategies, for example, to extend our bounding boxes in detection tasks, and we see how the quality can be improved. Or we can try different tasks for the same problem, because sometimes the users even don't know which type of computer vision project to select when they start. But again, when you use tools like Getty, no-code tools, you can do it very, very quickly, and you can select different types of projects for the same problem and compare the performance. So if you want to try this tool, you can get it from the links I provided here. You will need to install it on server or on-prem or on cloud, and the hardware requirements are quite reasonable. And as I said, all the models have Apache 2.0 license, and they are okay for commercial purposes and for research purposes, of course. And all the data sets actually you create on Getty, they will also have commercial license, Apache 2.0 license. And if you're interested to learn more, connect with me on LinkedIn, and let's keep being in touch.